All right, so I'm going to sketch this sec function with all of these different transformations. Now I know that the reciprocal of sec is cos. I'm going to start by making a simpler cos function here. Y equals to cos 0.5 x minus pi over 4. So I'm only going to take the k value and the d value. I don't want to worry about the a value or the c value. I want to sketch this cos function first. So I know my k value is 0.5, so my period is 2 pi over 0.5, which is basically 4 pi. I want to do a quick sketch of this function, and I'm going to use the sketch of this function to sketch the reciprocal function. So I have this cos function here. A cos function usually starts at the top, but this one is phase shifted by pi over 4 to the right. So my initial maximum is going to be here at pi over 4. And then I'm going to add a full period to give me my ending point. So pi over 4 plus 4 pi is just 17 pi over 4. Now I'm going to do the midpoint of these two to find my minimum. So I'll do that on my calculator. Pi over 4 plus 17 pi over 4 divided by 2 is 9 pi over 4. And then I'll find my two zeros here. The zeros are really important for the reciprocal function. So I'll do the midpoint of these two, which is just 5 pi over 4, and this one will be 13 pi over 4. And then I'll just sketch this out really quick. I know that my cos function with just the x transformations would look like this. Now, my zeros of this function are going to be my vertical asymptotes of my reciprocal function. I'm going to start with my reciprocal function here. I'll draw this one a bit bigger. My zeros are 5 pi over 4 and 13 pi over 4. I'm going to make vertical asymptotes at these two places. X equals 5 pi over 4 and x equals 13 pi over 4. And now I know that my equation of axis is positive 1 over here. I know my amplitude is 2. So that means my two y values, my key points, is 1 plus 2, which is 3, and 1 minus 2, which is negative 1. So these are going to be the y values of my maximums and minimums for this sec function. Now let's take a look at this again. I know that I have a maximum here at pi over 4. So at pi over 4, I'm going to have a minimum. Your maximum here turns into your minimum. This is going to look like this. It's going to be another asymptote here, which we can find as well. And I'll show that in a bit. And then over here, I have my minimum at 9 pi over 4. So at 9 pi over 4, I have my maximum. It's basically going to look like this. So if you look at the original function, this is above the axis on this side. So I have to be above the axis on this side. And my maximum turns into a minimum. And then if you look at this side here, this is below the axis, which means that this should also be below the axis, and my minimum turns into a maximum. And the minimum and maximum values are just derived from your equation of axis plus or minus your amplitude. Okay, if you want to sketch more waves of this, you could. It's going to repeat in the same pattern on both sides. It's just going to look like this. If I want to find the x value of this point here, I just have to add my period to this minimum. So pi over 4 plus 4 pi is just 17 pi over 4. I'm going to have another asymptote over here. If I want to find this asymptote, I just go to this asymptote and I add 4 pi. So 5 pi over 4 plus 4 pi is just x equals 21 pi over 4. You can also see the difference between each of these are just 8. So you could always do it that way as well. So this one would be negative 3 pi over 4. And that is how you sketch a sec function with different transformations.